All right. So, as I said earlier, I'm going to solve this cubic equation using synthetic division, which is the other method besides long division and inspection. I'm only doing that for the sake of those of you who might like that method, okay, but I don't like it, which is fine. Okay, you can decide which method you prefer. Now, when you are given a cubic equation, because the degree of the polynomial is 3, it's not that easy to factorize it by inspection, okay, or just by observing the polynomial. So you have to use the factor theorem first to determine the first factor or the first linear factor. Okay, you use the factor theorem. So you say let f of x be equal to the polynomial. So that will be f of x equal to 2x cubed plus 9x squared minus 17x plus 6. All right? The next step is now to use the factor theorem. Remember, when you are using the factor theorem, it's trial and error. You substitute plus or minus 1. If you don't get 0, you move on to plus or minus 2. If you don't get 0, move on to plus or minus 3. As I told you last time, in most cases, by the time you get to plus or minus 3, in most cases, you must get a remainder which is equal to 0. Okay, so I'll start with F1. Okay, also, I just want to remind you, because sometimes this can slip away. This value which replaces x there, x equal to 1, it is also called the root of the cubic equation. Okay, remember, when you did quadratic equation, you solved the quadratic equation, and I think this, I'm not sure whether it's this class or my grade 11 class, I told you that when you solve the quadratic equation, the solutions, the answers you get are called solutions, they're called roots. Sometimes when you're dealing with a graph, we call them the x-intercepts, okay? And they're also called the zeros of that quadratic equation. Now, the same names can also be used when you're dealing with a cubic equation. So we have f1 here equal to 2 times 1 cubed plus 9 times 1 squared minus 17 times 1 plus 6. You simplify that, you get 8 plus 9 minus 17 plus 6. Okay, so this will give me 1723 there. So my 8 plus 9 is 17, so you get 6. Which 2?
2 times 1. 1 cube is 1.
Oh, sorry. Okay, so that's supposed to be 2 plus 9 minus 17 plus 6. So that will give me 17 minus 17. So you get 0. Thank you for that. Okay, now what this means is x equal to 1 is a root of that cubic equation. It also means that x equal to 1 is a solution, okay? It is also a 0 of that answer, of that cubic equation. So we can say, therefore, x is equal to 1. Therefore, x minus 1 is a factor, okay, of f of x. So we have found the first factor. All right. Now, we are going to move on to using synthetic division. Hopefully, you understood the other two methods. Now, to use, okay, when you are using synthetic division, you need the root that we got here using the factor theorem. We need that root when you are doing synthetic division. So the next step, can I carry on? Right. Here, we are also going to need the coefficients. Okay, these coefficients here, I'm going to need them when I'm using synthetic division. Right, so I've got 2, 9, minus 17, and 6. Right, so let's go to the next page. All right, so it's more like you are doing long division, but slightly different. Okay, so I'll put my first root there, which is x equal to 1. Okay, then the first coefficient, which is a 2, that's the coefficient of x cubed. Okay, and the next coefficient is 9. So we're going to have 9, then minus 17, and then we have positive 6. Okay, now you draw a horizontal line. Okay, now the first step when you're using this technique, you drop down that 2 or the first coefficient. Okay, you drop it down under the horizontal line. Then you multiply this 2 by the root, or rather by the first root, which you got using the factor theorem. You get a 2. That product, you put it below 9. For this question, you put it below 9. Then, the next thing now is for you to add. Okay? You add. So it will be 9 plus 2, what do you get? You get 11. Alright? You following that? Hey. You following? Okay. Now we are here. You multiply this 1, which is the first root of the cubic equation, by 11, and then you get what? Positive 11. Then you add again these 2, you get minus 6. Okay? Then this 1 times minus 6, you get minus 6. 6 plus minus 6, that will give you 0. Okay? Now, when you are doing synthetic division, the last number below this horizontal line, the last number, it has to be a 0. If it's not 0, then it means something is wrong. It has to be a 0. Okay, then, if you remember in the last lesson, I told you that if you multiply a linear factor by a quadratic factor, you get a cubic polynomial. Okay, now, our quadratic polynomial now, its coefficients are going to be those 3. So this will be your A of the quadratic polynomial, that's your B of the quadratic polynomial, and that's your constant term C for the quadratic polynomial. So what that means is we can write this as x minus 1 times 2x squared minus 11x minus 6 is equal to 0. Remember, we are solving the quadratic. We need to solve now this quadratic polynomial. Yes?
What do you say minus 11?
Where?
X squared minus 11.
Oh, it's supposed to be a plus. Can you speak up? Okay. Alright. Can someone factorize this? The quadratic polynomial get x minus 1. Factorize that.
X plus 6
X plus 6, 2x minus 1 equal to 0. Okay. Now, when you get here, it becomes so simple. Therefore, x is equal to 1, or x is equal to minus 6, or x is equal to a half. Okay? So those are your what? Your solutions or your roots of the cubic equation. Okay. Later on, when you do the graph, those 3 values that you see, these ones here, 1, 2, 3, they will be your x-intercepts. Okay, when you do the graph. That's why you have to start knowing how to solve the cubic equation, how to factorize and stuff like that before you start doing the cubic graph. Okay, so you now have 3 methods. Okay, then by the way, as well a question. 3 methods that you can use together with the factor theorem. Right? I just need to emphasize this because sometimes if a question comes in examinations like this one here, it gives you a cubic equation and they ask you to solve. This is how you will do it. You must start with this part. This is very important. Okay? That's very important. Where you start and the way you set it out is very important. And you must show the factor theorem. You have to show that. Okay. Then the last thing is the use of the calculator. Okay. The last thing is the use of the calculator. Okay. In your previous grades, what was the definition of an increasing function? Increasing and decreasing functions. What was the definition from grade 10 and 11?
The gradient is greater than 0 or less than 0.
So that's a calculus definition. What is the definition of an increasing function? Yes, question?
As the x value increases, so does the y value for increasing.
Yes. So in previous grade, okay, even if your teacher told you about the gradient, that definition was a calculus definition. Remember, differential calculus is about gradient. So if you're given a definition based on gradient, that was a calculus definition. Okay? Now, in general, in the lower grade, that is 10 and 11, an increasing function is a function such that as the x values are increasing, the y values are also increasing. Okay? That's a simple definition from lower grade. A decreasing function is one whereby as x increases, y decreases. Okay? Now, in this grade, we are going to define now an increasing and a decreasing function based on gradient. Okay? So, let's talk about increasing function. Increasing functions. Increasing function. Is I want to write this point down. A function f is strictly increasing. A function f is strictly increasing. A function f is strictly increasing over the interval AB, like that. The function f is strictly increasing over the interval AB if f prime of x is greater than 0, if f prime of x is greater than 0 for all, right, make sure you write it like this, for all x is an element of AB. Yes. Okay. I used what's called interval notation here, so don't get surprised. Okay, this x is an element of AB can also be written as A is less than x is less than B, like that, using inequalities. Okay, remember that from grade 10 when you taught interval notation, set notation, and all this stuff. Yeah. So if you've got an interval AB, okay, if you've got an interval AB such that within that interval, if you draw a tangent, the gradient, if the gradient is greater than 0, then we say the function is strictly increasing within that interval. Because one function can both increase or decrease. Sometimes it can increase, then decrease, then increase. In the case of a cubic graph or a cubic function. Okay, so make sure you know that. Right, the next point. For all increasing functions, the gradient is positive. For all increasing functions, the gradient is positive. Right? Let me draw a sketch for that. Let me draw the sketch here. So, if I give you a Cartesian plane, let's just talk about, let's say, an exponential function like that. If that point is point B, maybe this point here is point A. Okay, we've got an A value there. We've got a B value. We draw a tangent like that. Okay. The derivative must be greater than 0. Okay. Right? So if you want, you can add that in your book. That's a scenario. Remember, when we are talking about increasing functions or decreasing functions, we are referring to nonlinear functions. Okay? We are referring to nonlinear functions. We don't worry about the linear function because it is easy and very straightforward. Okay. Right. Decreasing function. Decreasing functions. Right, please write this down. A function f is strictly decreasing. The function f is strictly decreasing. The function f is strictly decreasing over the interval AB. Over the interval AB if f prime of x, or the first derivative, is less than 0 for all x is an element of AB. Okay. Then you put a full stop. And then the next point, you must write this down. All decreasing functions have a negative gradient. All decreasing functions have a negative gradient. All decreasing functions have a negative gradient. Full stop. All right. Right, then the next heading. Next heading we put on stationary points. Okay, stationary points in the lower grades, that is 10 and 11, generally we call them turning points. Okay, in calculus, these two can be interchanged. Stationary point, turning point. Okay, stationary point, turning points. All right, can you please write this down? Always remember that the gradient of a function always remember that the gradient of a function and the gradient and the gradient of a tangent at a point are equal, right? That is mt, that t, the subscript is for m tangent. Mt is equal to f of prime. If we choose a value of x there, they are going to be equal. So if you choose a point along a function, choose a point, draw a tangent to that point, the gradient of that function and the gradient of the tangent at the point of contact are going to be equal. Okay. Now the next point, at all stationary points, in brackets, turning points, at all stationary points, in brackets, turning points, the gradient of the function and the tangent are equal to 0. At all stationary points, brackets, turning points, the gradient of the function and the gradient of the tangent are equal to 0. When you put a full stop. Let's just draw a sketch of that. So what I'm talking about is this. If I give you a quadratic function, because we haven't done the graph of a cubic function as yet, right? At this point here, that's where you have your turning point. So it's a horizontal line. If you draw a tangent, it's going to be a horizontal line. Okay? Now the gradient here of the tangent is 0. Okay? Let me call this point A. Okay? Allow me to erase this. So this is going to be equal to f of A, and both are going to be what? Equal to 0. Right? We're talking about at the turning point. Right. Now, last year, when we were trying to find the turning point of a quadratic function, remember, I think you have two methods, because it's very important for me to connect the quadratic function and what we are doing now. It's very important. Last year, when you're finding the x value at the turning point, remember, use the formula x equal to minus b over what? Over 2a. That was one way to find the x value at the turning point. Or you use the x-intercepts if they were provided. Okay? If they were provided, because the turning point, okay, is actually a point in such a way that the axis of symmetry passes through the turning point for a quadratic graph. So if you have the x-intercept x1, okay, so your x there was equal to x1 plus x2 all over 2. You remember that? Yeah. That's another way of finding the x value at the what? At the turning point. Now there's a third way using calculus, which you can now use from now on. Right? All you have to do is find the first derivative. You can use this when you're dealing with a quadratic function. If they ask you the turning point, you find the derivative, then you equate that first derivative to 0. It will be a linear function, remember? The derivative of a quadratic function is a linear. So you get a linear function, you equate it to 0, you solve for x. Okay, so you should not get stuck when we come to find the x value at the turning point, because there are now 3 methods of doing the same thing. 3 methods that can give you the same answer. Okay, those two from grade 10 and 11, and then calculus. Okay? And all solutions are provided when it comes to the memo, because people think differently. All right, then if I choose another point, say somewhere there, okay? If I draw a tangent to that point, okay? Let's say this point here. Then, okay, I'm going to call the value of x at that point, maybe say b. Okay, please, you can choose any letter you want. Mr. Tuponda chose b, so that's my b. Okay, just to remind you, to the left of the turning point for this graph, it is increasing. Therefore, f prime of x will be greater than 0. Also, f of b, okay, f prime of b will be greater than 0. Remember, b is an x value. So if we substitute the value of b into the first derivative, which is a linear function, the first derivative of a quadratic function is a linear one. You substitute the value of b, you get your gradient. And that gradient must be positive. In line with the definition of an increasing function, I'm talking about that point. Then, if we have it on this side, we draw a tangent. Okay, let's call that point there, point C. Okay, at this point, the function is decreasing, which means the first derivative must be less than 0. And if you substitute the value of C at that point, you must get a derivative, which is negative. Okay, and obviously here the gradient is 0. And your gradient of your tangent plate is going to be given by f prime of c. Here it will be given by f prime of c. Okay, so I'm just using this diagram. We can have one with a minimum turning point, but the concept is the same. If you want, you can sketch the one with the minimum turning point. Okay. All right. Let me move on to another aspect now. Any questions? Any questions? And if you don't have any, okay, you need to be very careful about the shape of a cubic graph. Okay, it is determined by A. A is greater than 0. You start with a maximum turning point, then a minimum turning point. Now, it's not always the case that a cubic graph will have 2 turning points. Okay, 2 is the maximum, but sometimes it can have, it can only have a point, so a point so it can have a situation where a stationary point is also called the point of inflection, whereby it will look like this. It can look like that. You can have a cubic function, okay, which looks like that. Okay, so the shape that does not look like this one only, it can also look like this, depending on the equation. In most cases, if the shape is like this, it means B is 0, okay, and probably C as well. So it means you only have AXT plus D for you to have this shape. It's also a very much possible shape for a cubic function. Okay, now for this one, it's very unique. We are going to talk about some examples later on. That one there. Right? So this is the shape. Okay, now I'm sure you can see that both of them, when A is positive, they start as increasing functions. Okay, when A is positive, they start as increasing functions. That's very important. That can also help you to remember how the shape looks like. Okay, then let's move on to the next case. When A is less than 0, you start with a minimum, then a maximum turning point. Okay? Or it can start from the top, it goes down like that. Okay? So you can also have a case like that. So those are the shapes. Okay? The shape of the graph is very important, as we were taught in the lower grades. Knowing the shape is very important. Okay, then let's move on to another aspect, which is the turning points. The turning points. The turning points. So that's number 2, turning points. Okay, in brackets, just write stationary points. Please write this point down. A cubic graph can have at most 2 turning points. A cubic graph can have at most 2 turning points. Right, full stop. At the turning points, the gradient is 0. At the turning points, the gradient is 0. At the turning points, the gradient is 0. Right, I want you to draw this. Okay, let's start with a function that has got the value of a which is positive. Okay, so here's your turning point here, another turning point. Okay, we want, let's call the value of x, that turning point, let's call it a, and the one at the second point, let's call it b. Okay, remember here, f prime of x is 0. Okay, and also here, f, in actual fact, you can put the value of a there, where there is x. So you can write f prime of a equal to 0. Put a there. Let's put a. F prime of a is equal to 0. And here, it will be f prime of b is 0. Okay. Please don't get confused. A and b are x values. Okay. Then, to the left of the maximum turning point, the function is increasing, which means f prime of x, it will be greater than 0. Right, and then on the other, and here it will be decreasing. Right, and there it will be increasing. So f prime of x is greater than 0. Here f prime of x will be less than 0. Okay, the next lesson will carry on from here. Carry on from turning points. Because we need the other case. Okay. So please, you don't forget to do your homework, the 4 questions on rules.